Inspecting the leading edge, we find extensive stress fractures, highlighting the critical nature of this repair.
Calibration looks good on the leading edge.
Volumetric data is streaming now, confirming the impact depth.
Look at the red here. Look at the red zone here.
That's significant subsurface delamination near the leading edge. The stress analysis
Look at the temperature differential here. That purple spot indicates water ingress.
Agreed. The robotic scan captured it perfectly.
Look at the extent of this delamination right here. It goes deeper than we thought.
Yes, the fiber breakage is critical. We need to assess the structural impact.
The data aggregation clearly shows the extent of the composite damage here.
We should use the automated fiber placement for the repair.
The precision laser ablation system removes surface contamination without compromising structural integrity. The excision path looks perfect based on the scan data.
Agreed, the vacuum capture is nominal.
The containment bin, filled with severely damaged composite fragments from the Mitsubishi F-2B, is transported.
Ensure the orientation is exact on this curve.
Applying heat now, slowly.
Check the fiber alignment before smoothing.
This specialized roller presses out trapped air, a vital step in the repair of the F-2B wing.
Layer by layer, the composite plies restore the aerodynamic profile. This advanced hybrid manufacturing
Half section clear on the left, keep it coming slowly.
Copy that, moving at 5%.
Sequence 49 initialized. Begin scan.
Confirmed. Data streaming live.
As you can see here, the consolidation is perfect. No voids or delaminations in the Mitsubishi F-2B wing structure.
The manifest confirms the serial number match.
All right, proceed with the Process A sign-off.
Product A secure in Bay 4.
Confirmed. Status finalized.
The feedstock looks good. We are ready for molding.
Confirmed. The Mitsubishi composites are fully repurposed.
Utilizing advanced robotics, the recycled Mitsubishi F-2B composite is refined for its new purpose as Product B. The robotic arm carefully places the stack of composite test coupons, ensuring the integrity of Product B, recycled from the Mitsubishi F-2B wing.
Manifest confirms the F-2B composite shipment.
All quantities verified. Ready for loading.
Pallet 78B secured.
Confirmed. Ready for bracing.
This critical test evaluates the mechanical properties and strength of Product B, demonstrating its utility as a high-strength, recycled material.
If we use Product B for the tooling,
We cut weight by 40%. Yeah.
and the thermal stability is excellent. See the data here.
spectrometer confirms zero degradation after thermal cycling.
Remarkable resilience. The product B validation is complete.
The strength to weight ratio on these F-2B coupons incredible.
Yeah, look at the shear stress data here. Yeah. We should integrate them into the fuselage design immediately.
By using the recycled composite derived from the F-2B wing program, we've achieved a much lighter jig that maintains.
The industrial utility of Product B is clear, enhancing the safety and efficiency of global supply chains for these high-tech goods.
A worker uses a dark gray composite shim to precisely level a heavy piece of machinery. This application
The continuous assessment confirms the reliability of Product B, derived from the Mitsubishi F-2B wing.